I'm Vivek. I have been in the SRE space for a long time, and I help customers balance reliability and cost of their applications, also known as SRE, right? So that's what I do. So today the topic is on Coroot implementation, okay? But before going into the topic, I just want to set some context on what motivated me to have a session on Coroot, right? If you look at 15-20 years ago, you had this distributed architecture from monolith. Enterprises were migrating to distributed architecture, and we had app servers like Oracle WebLogic, IBM VAS servers, right? Which had like nice three-tier architecture. You have a web layer, you have a app layer, and then a DB layer. At the time, you didn't have a lot of moving parts, right? You had this one huge JVM, and then you just bin packed a lot of the Java applications on that JVM, right? And typically, operations team or support team, you didn't have SRE team back then. They weren't called SRE team. So what they would do is they would just go to that WebLogic console and they would monitor what applications, how many threads are, concurrent threads are there, what are the out of memory issues that are happening in each application. So those things they would do, and that was okay, right? So the individual monitoring console gave the monitoring capability or observing capability at that point, right? So that worked for those distributed applications where we just had three-tier application, right? That I would call as like observability 1.0, the very first version. That it was not observability, it was just more like a monitoring that you got. You got the behavior of those JVMs, and from a infra perspective, from app perspective, from a thread heap dump perspective, all those things. And then we moved to, after the microservices architecture came, right? People moved from three-tier architecture to n-tier architecture. Now you had a single workflow go through multiple microservices all the way back to the database, and then came all the way back to the user, right? So you had, instead of just 3 layers, now you had 10 microservices. So there's a lot of moving parts here, and suppose there's a spike in the UI, right? UI time, where do you go and look into, right? So now you have to look into this. You can't look into this log, take a log for these 10 microservices and then go and do your root cause analysis. That's going to be a real nightmare, right? Earlier with Oracle, like distributed services, that's what people are doing. They would just start from your web layer, then they would say, where is the spike? Where is the latency spike? Then go to your, for the same time, look at your app layer. Where is the spike? Then go to your DB, right? That was what was happening. But with that, what happened is we got Prometheus, which is like the whole thing that started this observability itself, right? So you just install Prometheus in a cluster, and then you would get all the metrics delivered right into your dashboard, right? You didn't have to do a lot of installing and other things, right? And then we had OpenTelemetry, where you had visibility into traces and logs through Elk Stack, Fluent Bit. This I would call it as, and then the 3 pillars of observability, which is like logs, traces, and metrics were established, right? And additionally, like profiles were added, but like log, traces, and metrics were the very first thing, and that was established as the key pillars for observability. And we had all these data in a nice dashboard, but still what happened is people had to juggle between dashboards. People had to maintain these 3, like for Prometheus, you had to maintain a separate YAML file, Elk Stack, Elastic Stack, another set of YAML file, and then for OpenTelemetry, you had to maintain the collectors, and then you had like separate CI/CD pipelines for these. And then imagine, this is just for implementation, and imagine the vulnerabilities that you have to deal with, the end-of-life support for each of the agents. So the workload kind of tripled, basically, right? And imagine with the number of clusters you have to maintain, number of VMs that you have to maintain, and it was just exponential, right? So that I call it as observability too. But now, where we have gotten into a point is, especially with eBPF technology, which I think the previous speaker was talking about the security aspect, like through Cilium. So how many are aware of eBPF? Okay, cool. So just at a high level, so it's nothing but a sandbox environment where you can run your user-generated code in the Linux kernel in a more secure way. So how we use it for observability? We use it to eavesdrop what's happening in the node, what's happening inside the process, like which process it is calling, which network call it is making, which disk it is accessing. So all those things you can really eavesdrop without adding a separate agent for each of these use cases, right? And that's where now, if you see in the last couple of years, you will see a lot of use cases with eBPF, especially with security, with observability, and even with API testing and other things like Deploy and other tools. Right? All these things are eBPF based, technology based tools, and this I call it as Observability 3, right? 3.0 version. So the reason why I'm saying this is you wanted observability to be like a commodity, right? You don't want it to be like a pet. You want it to be like a cattle. That's the whole reason for Kubernetes, right? You wanted to treat VMs as cattle and not you don't want to pay individual attention, right? You want to spend the time, you want to be able to scale an operations team maintaining multiple clusters, multiple nodes without scaling the team, right? And that's where, that's the context that I want to set, right? So the time spent with individual clusters, especially with observability, is being reduced. And with the operational cost that is being asked from the management to reduce, this technology is going to really be a game changer, especially in the observability perspective. So having said that, so this presentation is going to be an implementation that I did for a customer. So I'll just walk you through what were my thought process, how I did the implementation, and we'll end up with the demo. Okay. So the customer that I had, just to give a little bit of background on what, so it's a typical enterprise customer where we had infrastructures from like VMware, and then we had like a containerized workload running on-prem, and then we had workload in cloud, basically AWS, Azure kind of workloads, and there are like some legacy applications also running C++. Okay, so we had the infrastructure was just carried over from multiple years ago. The requirement for observability was it should work for VM as well as for Kubernetes. It should not be just cloud native or container native, right? It has to even work for the older kind of infrastructure. And if you look at the workloads spanned from like WebLogic, Oracle WebLogic servers to individual VM-based scripts to Kubernetes-based architecture, Kubernetes microservices, basically. And they are all like asynchronous, synchronous, and event-driven architecture. So all these things, there was a mix. And we had like Kafka for event-driven architecture and a little bit of MQ for that as well. And existing monitoring tools that we had was Prometheus, which were there. And then we also had legacy WebLogic consoles people are using. And there was also some Dynatrace, right? Now, why did we have these three different observability tools? Because different teams were in different stages of their maturity model, and based on the team's maturity, they adapted different open source tools, and that really was causing a problem. That was the main intention, to look at it from a holistic perspective and to try to consolidate all these open source tools and like proprietary tools into just one sort of a view where we can get, instead of playing around with multiple, anyone who would have been involved with fixing security vulnerabilities, and if you're having like Elasticstack and Prometheus, you would understand, right? Especially with the community editions, you'd have to, it would go end of support maybe every 2 months. Elastic is very notorious for that, right? And that kind of snowballed into a problem, and this is when we decided that we have to have a consolidated view, and we have to consolidate all these open source tools, especially in the observability area, right? And that was the intention for this. And so any observability tool, we had three major consumers of these reports, or the action items that came out of this observability. So obviously the dev team, the SRE team, which are part of the product team, and then they are usually, like the dev teams are usually, they worry about the APM, like the profiling. They are more worried about which part of the code is causing the problem, right? They are more granular. And SRE team and infra guys are more like, okay, is the service up? What is the latency? What is the SLO? Is it meeting? That kind of report, right? So these two teams require different types of reports from different types of dashboards, from different types of agents. That was what the existing practice was. And executives were more like, okay, what is the cost of the system? What is the capacity going to be next year from a forecasting perspective? And how well behaved my systems are they meeting the SLAs and all those things, right? So that's their perspective. And then the GRC team, the governance risk compliance team, they were more into security and risk of the applications. And so they were more they would do audit using like SIEM, SIEM, those type of tools and those type of dashboards where they were concerned about, okay? So this is the problem that you're facing, and this is the baseline that we had, that we were trying to address, basically. Okay, so that was the existing state, and the target state was where do you want to go, right? So we wanted full stack coverage, which meant looking at the infrastructure metrics, especially for the infra team and the cloud team and the SRE team. And we also wanted to understand how the tracing happens, the service level mapping across microservices, which could be synchronous or asynchronous. And then the profiling, which is very useful for the application developers, basically when they have to debug a particular problem. And also what's happening inside database, right? Which query is running longer, which thread is running longer, and those things, right? So we wanted a full stack coverage, and we also wanted it to be lightweight. We wanted just one set of one agent to be able to achieve this, rather than having three set of tools and three set of tools from three vendors, and then monitoring these, managing these agents all through the life cycle, right? So that's, and the third thing is we wanted something out of the box, so we don't have to customize everything and create another pipeline for it and manage it, and also we wanted it to be extensible. So if there is something that we can integrate that with our PagerDuty or Slack, then we wanted that, especially customization in that perspective. So these were the 4 key requirements that we worked towards. We did a comparison before we narrowed down on the tool. So we chose Dynatrace because they already had Dynatrace for a small part of their LOB, and it's also a proprietary tool. And then the second alternative was OTel, OpenTelemetry, and Signos, which is it will give the big observability picture, right? Both log metrics and traces. And then eBPF based tool, Coroot. Now, why did we choose eBPF? There are many tools. New Relic has their own tool called Pixie. There are a couple of other tools. But we chose Coroot because Coroot has all the functions, like the majority of the more features than any other tool basically. And also, Pixie had, they have, they were not as lightweight as Coroot, right? They had their own way of storing data, which you can't access outside of their API layer, all those things that were there in Pixie. So that's why we chose Coroot. Now, comparing across these 5 metrics, right? So full stack coverage, I would say, like Dynatrace, actually OpenTelemetry doesn't have profiling. I mean, that is the only reason why it doesn't have that. But otherwise, it has logs, metric traces, right? And then like Coroot had profiling. Dynatrace also has profiling, but Dynatrace has additional things where it can give a bird's eye view of all the things, right? From the user call until the very back end, it will give you just one perspective, but Coroot can't give that now, at least. But maybe in the future they will do that. But that is the only difference between Dynatrace and Coroot, right? But OpenTelemetry, it was definitely not the one that we're looking at. Lightweight, definitely, I think Coroot and Dynatrace. Dynatrace has one agent, and Coroot also has just one agent at a node level, and you can just install it, and then you don't have to do much. It also works out of the box. Dynatrace, I think, it doesn't work much out of the box. You still have to configure a lot of the metrics. Coroot has an opinionated set of dashboards, opinionated set of alerts. You can configure it to your incident management system, So I would say Coroot is a little better in out of the box. Scalability, I don't think there's much difference. Everything has collectors, and you can scale the collectors horizontally until you get to the database. But there are ways to even scale the database across all these 3 tools. So there's not much difference, real difference there. Cost effective, Dynatrace is very costly. Anyone using Dynatrace, it's very costly. They haven't, at one time, Dynatrace was the only person who could solve this before Signos came, right? Like logs, metric traces, and profiling. But then there are other tools that caught up, other open source tools that caught up with Dynatrace. And Coroot, they have like community version and they have enterprise version. And community version doesn't have a lot of the features that we liked, especially the eBPF based tracing. It had profiling though, but not tracing. But if you go to the cloud, the enterprise version, they had that, and that was what we chose basically, right? Because we didn't want to be in a place where we have to maintain these agents, and then we want because it's a newer open source tool compared to Signos and OpenTelemetry space. We wanted to have a license with the vendor, so that's why we chose that. Okay. So overall, if you look at it, like Coroot was the winner here compared to Dynatrace could do it, but Dynatrace is very costly, right? And that's why we moved to Coroot here. Right, a little bit about Coroot. It is a unified agent, although not technically. It still has, it's a daemon set. You install it through a Coroot, through operator, and then it will install itself in every node. It's run as a daemon set. For all the apps, you can do that, but specifically, if you want to get what's happening inside a database, what's happening inside a Redis and other databases, MySQL and things, you have to install something called cluster agent, right? Which is at a cluster level, not at a node level. So that's the only thing. And configuration-wise, you don't have to do a lot of configuration changes. You just have to install it using the operator, and it will pick. You can enable it out of the box. Say, for all the process in the namespace in this cluster, just enable it. You can do that. You don't even have to tell it. You can say, for a particular namespace, enable. For a particular namespace, disable. Like, you can do all these combinations, right? And for a particular pod, do this particular, like through a pod selector, through a namespace selector, all these things, right? If you want, you can omit and filter pods in namespace based on the selectors, basically, right? And support-wise, like there are other tools in eBPF which didn't support VM, but what we liked about Coroot is it supported VM, basically, right? So you just install a agent in the VM, and it will figure out what's running on top of what all processes are running in that VM, and then it will start pulling in all the data, basically. Right? Extensible, so it has there's also AI-based RC analysis that you can do that comes with the enterprise edition, not with the community edition. So you can really, it can correlate between your logs, metrics, and traces, and clearly say, okay, so this log, this is the metric, it will say the service is up or down, and this is the log at that time which is causing the issue, and then this is the exact point of code which is causing that log, which is writing that log, basically. So it can give that RCA, which is help basically in reducing the mean time to resolve the issue and do a lot of the RCA. It shrunk the RCA time, basically. Right? And we can have, even though it came with an opinionated set of alerts and dashboards, we can build dashboards on top of it. Okay, so when we deployed, we had like the VM, and then we have the Kubernetes clusters, and again, you can just deploy it through it does have a Helm chart, but it's much easier through an operator. So you had a cluster agent at a cluster level, which will monitor the databases, and you can give the credentials for the database, and it will go and fetch all the metrics. Like if you give a Postgres credential, it will go and get all the long-running SQLs in a Postgres and try to map it to your long-running thread. All those things it will do. And for every node, it will have a node agent, which is basically try to get the profiles, the logs, and the metrics for all the process that is happening, that is running within that VM, within that node, right? So ultimately, all these logs, metrics, size, profiles are collected in the collector, which is ideally, you wanted to put it outside of the Kubernetes cluster. You don't want your monitoring application to be in the same cluster that you're monitoring, right? So you just put it outside. Could be a VM, could be another cluster. But you used VM actually for this. And then behind the screens, collector, so you have to push all these data to collector, and collector will send metrics to Prometheus database, and it will send logs, traces, and profiles to ClickHouseDB. It's all under the hood, but I'm just saying it for your understanding. And it exposes an API, and it also gives a UI, basically. So a user can go and build dashboards on top of these collectors. I shouldn't say collector, on top of these Coroot UI. And it also exposes, so if you want to programmatically access it, it gives an API, so you can just access the data, basically, all the logs, metric, and if you want to push it to long term or do some upsampling, downsampling, all these things you can do, right, based on that. So this is the deployment that we had. From implementation perspective, so we divided, so this happened across 6 to 8 months duration. The first phase was to identify the different combinations or the different maturity level the existing teams had in terms of what metrics they were really interested in, and are they really developers looking for profiles, or what sort of data they were looking for, what dashboard they were interested in. So that was, so in the first phase, that's what we did, and then we went and spoke to different LOB teams and got their approval and wanted volunteers from each of the LOB for the initial pilot program, basically, right? We want to do a canary deployment, not just open it up to the whole world, right? So we did a pilot program, identified these volunteers, and then we were able to start slowly roll out with interested people, basically, right? So interestingly, what happened in the third phase which almost happened parallel to the Pygate program is, so we see ultimately if people don't use it, it's going to be a fail. Even though you get all the logs, metrics and everything, and if no one uses it, it's still a failed project, right? So you want to win the confidence of the existing team, especially the developers who would want to use this product, because it's not just for SREs, right? Earlier with Hotel and other things, it was, and for like Prometheus and everything, it was just for SREs, right? DevOps and SREs. No developer would look into metrics and other things, right? But now, because it has profiles, and we're able to give a singular view, and we're able to see what's happening in database, what's happening in the Redis cache and all those things, the developers had to be convinced really. So that's why we took them into confidence, and we really wanted some influencers sort of people, right? So they can go and convince their team, and then we would get a much more wider audience. That was the idea that we did, and it worked out okay, especially because they didn't have to do much in terms of maintaining it or in terms of that. And they were also interested when they saw the profiles basically, which kind of gave, see earlier we used to, when they were moving from, they're implementing Hotel, the SR team would talk to their development team and then say, okay, so guys, you have to include this Java package for to instrument your code, right? And then some didn't do. They saw that as work, but now through profiling, through eBPF tracing, you didn't have to do any of these things. You just got all the traces just at one shot, right? That was what they liked pretty much. And once we had we are able to convince the first set of people who really liked it, we were able to move ahead and do a rollout across the entire organization. Again, in not just one shot, but just in like multiple phases we did. Okay. Outcome-wise, we wanted a single source of truth. We didn't want to juggle through multiple contexts, multiple dashboards, multiple application across Prometheus, across all those things. So we were able to get that at one which had just a single source of truth. And this was able to bring down the RCA time, at least the initial POC that we were able to do. It was able to pinpoint much faster. And obviously, we did reduce a lot of our open source agents. So in terms of vulnerabilities, in terms of maintaining these pipelines, we did reduce a lot on these. And obviously, we were able to save the cost as well because of the optimized resource usage. And in Coroot, there is a feature where we can see the cost as well, but not at a very granular level. But at a node level, we can see the cost, and you give suppose you are using an Azure account, you can give the Azure credentials, and it will bring the Azure cost. Same thing with AWS. So it will give you more accurate cost of how much you're spending, right? So that's another feature. And yeah, out of the box, build dashboards, alerts. So what we tried to achieve is covered with this tool basically. So the one thing that we found out is, so to bring the developers into confidence and not just roll out and just get done with the job, that would have been a failure. So that's why we took a lot of time to explain it to developers, because they have to feel it useful, right? Otherwise there's no use, right, doing it. So we started small, and the CPU profiling helped without any instrumentation, and the configs were kept consistent. We didn't have to juggle a lot of the configs and to do a lot of customization. And finally, training, which we did parallelly with the POC to get the developers acquainted with the tool, right? So I have a small demo. Okay, we'll do that. Okay. So this is the app. Okay, so let's see. Yeah, this is the app that is installed, and then if you look at this, these three are it's a Zookeeper equivalent for keeping the states, which shows the metadata, right, for ClickHouse. And basically, this is a kind cluster I installed in my laptop, and then I installed Coroot operator, and I also installed a demo application, basically, right. So the first three is like the Zookeeper, which kind of keeps the ClickHouse database in sync, and it elect the master, right, those things that will do the ClickHouse keeper. And then I just had just one ClickHouse database, right? I didn't want to create multiple instances, right? And then the cluster agent, which will give you data about the database. You can connect it to your database, your Redis or whatever, and then it can go inside the Redis and analyze what's happening inside in terms of threads, connections, long-running SQLs, all those things, right? And the node agent is the one which is the main thing, will give you the logs, metrics, traces, and profiles, right? So that's the node agent there. And then the operator is because it's how it's installed, right? And it also has a Prometheus database, right? So internally, from our perspective, we don't have to do anything because it will install Prometheus. It's a Prometheus instance basically, because that's how the metrics are stored. Otherwise, ClickHouse doesn't have a way to store the metrics basically. It stores just the logs, traces, and profiles. Okay, so that's why Prometheus is used. So then So this is, I just forwarded it, I port forwarded it. So I'll also tell you the difference between the community edition and, so this is a full edition, it's not a community edition, right? This is an enterprise edition. So let's look at, so these are applications. So this would give you like instant visibility, right? You don't have to, there are no other YAMLs, no other, like for OpenTelemetry, you have to go and you have to configure your YAMLs and other things. Here too, if you want, you can do it, but you don't really have to do it, right? Because that's the way how it is set up, and you don't have to install any Java agents for Java workload, Python agents for Python workload, none of these, right? It would just, because the way eBPF works is, it just goes and eavesdrop into all the process for you, right? You don't have to have a specific language-based agent, right? That's the advantage for this. So this is the dashboard view. Maybe a little bit bigger, okay. So you can, these are all the applications, and you can see the service map here. Yeah, you can see the service flow here. And let's go with a particular Java agent. Yeah, you can see all the languages that are detected, the databases, all these things, right? Yeah, so if you go to this service, it'll show you the service map, and you can configure your SLO. You can say, what is the latency that you are looking for? Is it like 3 seconds, 2 seconds? What is the percentile? All these things you can configure. And you can see the instance availability, the CPU inframetrics, memory, the network time, round time, and then the JVM metrics. And then you can see the logs, and then you can filter the logs, and you can filter the logs here, I think. And then you can look at the Kubernetes deployment status, for this particular application. You can look at the profiling here. So this is how, so you can see which, at the code level, what's happening. You can trace it at a code level. You can also look at service level traces. You can see how the flow happens between, for an individual trace ID. So if you go here, you can see the traces here. Yeah, it's much more. And then, so the another thing is, if you already have OpenTelemetry installed, OpenTelemetry collector installed, you can even point Coroot database, I shouldn't say Coroot database, Coroot collector to OpenTelemetry. So it still ingests OpenTelemetry data basically for you, and then it will show you in terms of traces, right? So if you wanted to use in conjunction with OpenTelemetry, you still can do it, right? So that's another advantage that you have. So yeah, you can see the logs here, you can query it based on container ID and all these things, right? Yeah, these are node level metrics, so. Yeah, I think that's pretty much it. So any queries that you want to have?
As we started moving to distributed tracing, there are few fundamental logic that is lost. That is, APM can track requests that are greater than few seconds of latency. Whereas distributed tracing is completely different, where you cannot track requests that are greater than few seconds because there's already few spans that have left the system and you cannot bring that functionality here.
Correct.
So, is there any bridge that we can have with Coroot where you track certain requests beyond this latency and then have it sampled first and then have the rest of the samples?
Yeah, you don't have it right out of the box. I would say that you'd have to hack the agent basically, right? So the way this eBPF works is, it is nothing but an assembly language code written inside a sandbox. So you really have to, you can modify it, right? And you can modify it according to what you want basically. And that's what Coroot has done it basically, right? So that is the one way of doing it. And when you say distributed system, are you meaning like asynchronous workload as well? Kafka, MQ, other things?
No,
Pure. Yeah, so then I think if you have the header right, you should be able to figure it out, right? Are you talking about any specific scenarios that you are?
Transactions. If you are not doing a path-based sampling, so unless you have 100% sampling, right? Let's say a few of them choose 10% sampling if the volume is really high, and there are higher latency transactions that you want to track and fix, but it is not captured as a part of 10% sampling because it is random sampling.
Okay. So like giant trace would fall into that category, yeah, I see what you're saying.
Because that's where APM and distributed tracing has a difference.
Right.
Where only if you have 100% sampling rate, it acts as an APM as well as a distributed tracing.
Right.
With 10% sampling, we are unable to track the high latency guys first, but we are just having a probability of capturing.
Yeah, I see what you're saying. Yeah, that's a known problem. Yeah, that.
This problem in distributed tracing.
Right. Unless you see this, like again, right, you can solve it through multiple ways. You don't have to have 2 weeks of data basically, right? You can just have the last 2 hours of data and maybe have 100% sampling or like close to 100% sampling. If you know that if you're going through a big change, like there's a change happening for this particular day, there's a release day, then you can maybe increase the percentage in a sample percentage. That would be the easiest, I would say, rather than playing around with other things because you already have
Probably every release you can have
a window where you just monitor it.